Now, one thing we can do is we can scale it up. So what you could do is you could just have a multiplier and then multiply it and see where the 3 actually add up to 1. But there is another way to do it. There's two things. You can put bounds on your optimization, and you can also put constraints on. And the bounds are quite important because sometimes, let's just say you wanted to have a minimum weight of each of your assets. You see, this is like just below 10%. But say you wanted not 10, but your minimum weight should be maybe 20% for some reason, you know. So one thing you could do is you could do this BNDS, and then what you can do is you can introduce a list, and you could do something like your minimum is then 0.2, and your maximum, you could say, just for the sake of it, none. So it's unbounded at the top. And because we have 3 instruments, we do this for all of them. And so if you now do the optimization, you will find that obviously your Sharpe ratio isn't as good, but you could see that your weights are in fact, oh, they're not. Oh yes, of course, I haven't actually put the bounds here. So what we need to do is we need to go bounds equals BNDS and rerun the optimization. And now we should see that, yeah, see, then it actually forces gasoline to be exactly at 0.2. But what you can also see is it then makes the other ones higher to make up for it, to actually get the good Sharpe ratio again. So it scales them. And when you go here, res.x, you can see that it scales them up to 1.7 and 1.2. So when it does that, it basically, you know, makes it short because we don't have any constraints. How we define constraints, that's an interesting one. So there's different constraints that we can put in. And so some of them are using equalities and some of them use inequalities. So something is less or larger than something, or something is equal than something else. And so when we define a constraint, we need to define the type of our constraints. In our case, what we want is the sum of all our weights being equal to 1, right? And what we then need to do is we need to define this function of that constraint. And so what we normally do is when we define constraints, the function that we build should always equal 0. Yeah? So when we say, well, the sum of all our weights equals 1, then in order to get this to 0, what we do is we take the 1 on the left side, so we say the sum of our weights minus 1 equals 0. And that basically gives us this function here. So we get sum of our weights, which is in this case x. We could just instead, so just to be consistent, we could maybe use w. I just copied and pasted that effectively. So the sum of our weights minus 1 equals 0, right? We could also say, well, the sum of our weights should be 0. In this case, then we would just take away the minus 1. Does that make sense? Mm-hmm. So it's effectively an equation, whatever that function we have equals 0. And then what we need to do is we need to add that to our optimization. We go constraints equals, and then here we call that cons. And what I would say is we make our bounds a little bit smaller. We just put them to 20% for demonstration, so we don't need that anymore. And so what we can do is we can run this, and as you can see, it ran fine. So now with our constraint, and you can see that here we've still got a reasonably good Sharpe ratio. Now interesting, we want to see what we've got here. And so you can see that just looking roughly, we've got 0.5 something plus 0.4 plus this little bit. So what we can do is we can go res.x and we take the sum of that. And hopefully this will add up to 1. And this is how there we go. This is how we add up to 1. So all of our cache that we basically have 100% are assigned. And that's how constraints work. Now, we could say, well, our constraint could be 0 or whatever, but it really depends. Now, one of the things we want to also know is what's our function, or what's our Sharpe ratio for this optimization. See, it's just over 0.7. So that's actually pretty good. We're getting somewhere here. And this is, in a very simple way, how you optimize portfolios.